Good morning, everyone, and welcome to today's webinar sponsored by Rootstock Software. Our last topic was shop floor. Explore how ERP is used to create and maintain work centers, routings, and procedures. This is the 5th webinar in our ERP 101 webinar series. Our topic today is shop floor. See how scheduling the shop floor through ERP controls labor and machines. Moving on to some housekeeping. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something like this that looks like this on your own computer desktop in the upper right corner. You're listening in using your computer speaker system by default. If you prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. All attendees will be on mute throughout the presentation. You'll have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. Now we'll take a look at our upcoming schedule. Today we will be covering shop floor, see how scheduling the shop floor through ERP controls labor and machines. The next webinar in the ERP 101 webinar series by Rootstock Software is scheduled for November 29th and will cover the topic procurement. Link your vendors and purchase parts via ERP. Future webinar dates are to be announced. I would now like to introduce our presenter, David Bush, Senior Manufacturing Consultant at Rootstock Software. David Bush has 30-plus years of manufacturing and MRP, ERP systems experience. David was previously at General Microcircuits, Consona Corporation, and Relevant Business Systems. David will now introduce us to our ERP 101 webinar, Shop Floor. See how scheduling the shop floor through ERP controls labor and machines. Hi, David.
Hi, Dave. Thank you very much for that introduction. Appreciate it. Those of you who have been with us for the past webinars know that the last one focused our attention on building the shop floor database and creating routings for sub-assemblies and finished goods. And in doing so, we learned that the routings can be viewed like a bill of materials, and we even compared them with a bill of material used to plan parts requirements. But rather than planning parts, the routing is really planning time required in the various work centers to build the product. The bills of materials provide the ERP system with quantities of items that are needed to build a single assembly, including material that's needed to cover other things like scrap and setup. The MRP system, material requirements planning, then uses those quantities to plan time-phased material supplies. Well, routings do something very similar. They provide the ERP system not with parts, but with the time that's required to build the product at each step in the manufacturing process. But then how does a planner or someone who's scheduling the shop use that information once it's in the ERP system? Well, let's find out by taking a closer look at what we covered in our previous session. So just quickly, let's talk about that. Our last webinar focused on building the shop floor database. Up until that point, we've been focusing on parts and bills of materials, but now we're changing our focus to the shop floor. Like I said, routings are very similar to bills of materials, but they are a bill of resources instead of material. And so they're used to plan the required time it takes to build a certain item, not the parts that are involved. The routing provides the quantity of time that's needed for a single assembly, including the setup, run, and machine times. Very similar to the way a bill of material provides the number of components that are required to build a single parent item. ERP then uses that information for capacity planning, similar to the way MRP calculates material needs. But here's a good question. Why do we even need capacity planning? If we have the material and we have the resources in the shop to put it together into an end item, what is capacity planning going to do for us? Well, let's find out why we need capacity planning. There are certain problems that can come up in the shop that must be addressed. One of them is overscheduling our resources. Now, what does that mean? Well, suppose we have one machine that is needed to build several different items, and we need those several different items at the same time. Well, we may overschedule that machine and not be able to fulfill the requirements that we have in order to get the parts out to the customer at the right time. As the slide you're looking at says, it creates a bottleneck and the required work just won't be done. So if the scheduler is aware of this problem, then they can use that knowledge to balance the workload and get out of that situation. But there's another issue too that capacity planning helps with, and that's under-scheduling the resources. Now, why would we care about that? Well, to have a resource costs a manufacturing company money. And if the planner knows that that resource is available, it could allow the scheduler to make the most use of the resources that he's got so that he can even out the load. ERP shop floor capacity tools then give that information to the scheduler, but they go beyond that. They don't only give him the information, but they give him the ability to balance the load in the shop so the customer requirements can be met. Those of you who have been with us in the past may remember this drawing. This is a blow-up of a bicycle, and we focused our attention on this section of the drawing, the handlebar assembly. If we think about the bill of material for the handlebar assembly, we know that it takes a handlebar, and it took a stem, it took 2 grips, and a few other parts. I think a reflector assembly was involved, and that have to be put together to build the handlebar assembly. And MRP would use that information to determine how much of those different items needed to be ordered, how much was already in stock, what would have to be issued to the floor, and so forth to satisfy the customer requirement. But now we're going to look at this same handlebar assembly in a slightly different way. We're going to look at it in as far as the resources that it takes in order to build it. So let's think about it now. The first thing that needs to be done is the material has to be pulled from stores. Let's just say that that takes one person 1 hour to do that, and that's done in the store's work center. Once the material is pulled, the stem is sent to machining so that the hole can be drilled in it for the reflector assembly. Now, that takes 1/10 of an hour, or 6 minutes. It takes one person, and it uses the machining work center. Once that hole is drilled, the parts are moved to the assembly department. And the assembly department is now going to put all of those pieces together to form the finished item. That's going to require half an hour, one person, in the assembly work center. And then before that assembly is sent back to stock, waiting to be used on the final assembly, it's going to be inspected in the inspection work center, and that's going to take about 9 minutes, 1/1500ths of an hour, again, by one person. So what have we discovered here? Well, looking at the capacity that is required to build this handlebar assembly, we now know that we need one person in the store's work center for an hour. We need 6 minutes of one person in machining. We need another half hour of one person in assembly. And we need 9 minutes in the inspection department to perform that final inspection. So we're beginning to develop some knowledge that the capacity planning system will be able to use in order to determine whether we're going to be able to meet our schedule or not. So let's think about how this is actually going to be handled by our ERP system. Again, we'll use the example of how ERP helps us to plan material, because material and time are planned in very similar ways. Remember, for planning material, we required, or the ERP system, I should say, required accurate bills of materials that would provide the quantities of the components that are needed to build one parent. Additional quantities were also covered by the bill of material for things like scrap, setup quantities, economic order quantities, things like that, that would affect the amount of each component that we might need. Well, let's apply the same logic to building the item. We need to think about things like how much time is going to be needed at each work center. And you might think back to that previous slide where we talked about the specific amount of time it took to do each one of those operations. Now, is the time that's available in that work center absolute, or is it modified by some other factors? What I mean by that is, suppose your factory works an 8-hour shift. Do you really have 8 hours of time that can be scheduled? Probably not, because as we'll find out a little later on in our webinar today, there are things that can affect the full amount of time that really should be scheduled. Think about things like the breaks that the individuals take, lunchtime. There might be other downtime too that's planned or unplanned. Suppose the machine needs maintenance 2 or 3 times a year. Well, then it's out of commission and can't be used, and so that would cut back on the amount of time that is needed. And our capacity planning system is going to have a way to take that downtime into consideration when it's planning how much time is needed and how much time is available. Now it's time for us to see a real-life example of capacity planning tools as evidence of how this works. Now, I'd like to say something before we move on to the next slide. We're going to be looking at pictures or screenshots of Rootstock programs that are used for capacity planning. Now, it's never been the intent of this series of webinars to teach you how to use Rootstock. We're looking at things at a much higher level, just trying to really understand the concepts behind the ERP system. So we're not going to be training you on how to use any of these screens. Please don't expect that. Rather, what we're going to be doing is looking at how Rootstock can be seen as an example of an ERP tool that requires certain information and then presents information back to the users in a way that they can make use of it and satisfy their customers' requirements. So having said that, let's move on to the first screenshot of Rootstock. And this is a screenshot of a work center. And this happens to be the assembly work center, as you can see here. A couple of things that we want to look very closely at that the ERP system needs in order to do capacity planning is the information that's held within this box. You'll notice it mentions the total capacity of labor hours per day, the length of the production day or labor hours, and then total capacity of machine hours per day and length of the production day in machine hours. Well, the length of day determines the overall capacity for this work center for one operator. So in this case, the length of the production day for one operator is 8 hours. Capacity, though, is defined in hours for labor or machines times the number of operators. So if we were to put 2 operators in this work center, it would indicate a capacity not of 8 hours anymore, but of 16 hours using this formula. However, as I said earlier, we don't really have a full 8 hours that we can schedule. We know that work will not be done in this work center for 8 hours straight because of those mitigating factors, the breaks and so forth that are always going to happen. So how does the ERP system handle this? Well, you notice another field here called scheduling factor. A scheduling factor is a multiplier, a percent of the capacity that this work center has. So in this particular example, 1 tells me that so far we believe that we really do have 8 full hours to schedule in this work center. What I'd most likely see here is something like 80% or 85%. That would tell the scheduling engine to only schedule up to 80 or 85% of the total capacity that I have in this work center. So that allows me then to modify my time and make it more accurate. I wouldn't be overscheduling the shop or underscheduling the shop. I can actually go either way. So now let's see how the work center is used in the routing of the handlebar assembly. But let me make this comment before we move on. This work center assembly is only one of many work centers that would be defined within the ERP system in order to create a routing. So keep that in mind as we move on. Here we have another Rootstock screenshot, this time of the routing for that handlebar assembly. Now, I apologize if it's a little bit difficult for you to see, but I'm going to point out just a few things here that we need to consider. The routing includes the time to build one parent. It includes 3 factors of time: setup, run, and machine, each of which may be used, or one or more may be used. So if you look down here at operation number 20, operation number 20 is to assemble the handlebar to the stem. And sliding across, we can see that setup time is 0. What that tells me is that there is no time required to set up or prepare this work center in order to begin work. If I was working on a drill press or a milling machine or some other machine like that, there probably would be setup time, as you see in the operation immediately below this one, telling me that in order to drill the hole in the stem, for example, it does take me a little bit of time maybe to set up a form or whatever I need to do in order to be able to run and drill the holes in the stems that I have to do. The next field over to the right is my run time. This defines how much time it takes me to do one stem, or whatever this particular operation is referring to. So how long does it take me to assemble the handlebar to the stem? And then the next field is machine hours. Well, again, I'm not using a machine. This is all hand labor in the assembly department, so I don't have to schedule any time. So maybe you begin to get the idea of what we're accomplishing here. We are defining within the ERP system the time that is required in a work center to perform the procedures that have to be done in order to build this end item. So think about the similarities between the routing and the bill of material. Remember, the bill of material handles the material requirements or the components that are needed to build a single parent item. The routings handle the time that is needed to build a single parent item. And both of them, the routing and the bill of material, use factors to adjust the demands. So remember, the factors that were on the bill of material were things like scrap factor and setup quantities, things like that, whereas the factors used here are going to adjust up or down the amount of time or capacity that is actually available within any particular work center. So here we just have, we're looking at a very small piece of one very simple routing to illustrate how the ERP system gathers, maintains that information. It really provides the foundation for capacity planning. And now that we have that in place, we have a routing developed, we have our work centers defined. How are those work center demands actually planned? Well, the tool that's used by the capacity planning system and by MRP, by the way, is the work order. The work order is actually a document that tells the users what must be produced, in what quantity, and in what time frame. So this work order, Web 5A, is to build a handlebar assembly. In this case, we're only building one of them, and the due date is October 24th. So the work order is created possibly by, well, usually by the MRP system for manufactured items, could be manually created, but it provides the quantity of the parent item to be built, and that quantity is then used as a multiplier by the capacity planning engine to determine the total amount of time that is needed in that work center for that operation. It also provides the due date that's used to determine when the operations have to be completed, this due date up here, so that the capacity planning engine will use that date to determine when the capacity needs to be hit in that work center, when it needs to be used up in order to satisfy the demand created by the sales order or the customer's requirement. So now let's take a look at the scheduling tool itself. Now that we've provided all this information for the system to use, what does the scheduling tool look like? Well, in Rootstock, this is the work order scheduling tool. And it really is a very, very simple program to use. The program provides all of the work orders that have yet to be scheduled. And it allows the planner to select any one or all of those work orders to be scheduled in the shop. So the first thing the planner would do coming into this screen is choose the work orders that he or she wants to schedule. Now the actual way that this is handled varies by ERP systems, but any ERP system that has capacity planning will have some form of this program that the planner will use. You may wonder, why would they choose less than all of them to schedule? Well, it may be that they know that certain work orders are very, very important, and they want to make sure that they get them put into the schedule first. So they may schedule them and then come back and schedule less important or less critical work orders later on. Other things could affect that too that the planner would be aware of. After they selected the work orders that they want to schedule, they simply go up and click the process button on the Rootstock screen in order to run capacity planning, which will create demand on each work center specified in the routing for the quantity that's defined on the work order. So if it took 6 minutes to do one piece and we're doing 100 of them, then we know we have 600 minutes that are going to be scheduled at that work center. And that's pretty much how that works. You remember, too, that we had 3 kinds of time. We had setup time, run time, and machine time. Setup time would be the time it takes to put the machine together to handle the job that must be done, to set up the machine with the tools that are required, so forth, so that the user would be able to then use that machine and do all of the pieces that have to be drilled or welded or whatever has to be done to them. Runtime is the time it takes to actually do a single piece. So setup time is not a multiplier normally. Setup time is one, it might take 15 minutes to set up the machine, and then it's done no matter how many pieces you're working on. Runtime, though, is multiplied by the number of pieces that you're making to determine the demand on that work center. Machine time is typically used when the machine, it can run on its own. For example, the user comes and sets it all up, puts the material into it, and can walk away, and the machine does its thing. Well, the machine in that case still requires a certain amount of time to finish the operation on all the pieces. And that's why that machine would be scheduled. And typically, the determination as to whether you would schedule a user or schedule the machine is what is the limiting factor. Which one of those two things could cause a bottleneck in that particular work center? If we only have one machine, then you can only run one job. Even if you have 10 operators, only one job could be run at a time. So that would be the limiting factor, and a planner would want to know just how heavy is the burden or demand for time on that machine. Now, once these work orders are scheduled, how does the planner see the results so that he can work with them and make any changes that might be required? Well, Rootstock has a very interesting program that is used in order to accomplish this. The work order capacity planning workbench. The workbench defines a lot of information that the planner can use in smoothing out the load. Rootstock provides this very detailed workbench that it doesn't just display the current schedule of work orders, but it also allows the planner to reschedule them if needed. It allows the planner to very quickly find those bottlenecks or problem areas that are perhaps overscheduled or underscheduled, because it gives you a color-coded format. You notice up here, anything in green is within the capacity of that work center. Anything in red exceeds that capacity. The green that we see right here is the capacity within the assembly work center for these two work orders. Actually, in this case, this is two operations on the same work order that would be done one right after the other. But the fact that they're both green indicates that there's no problem with capacity at this time. Both of these jobs will be able to be done as they are scheduled. Now, as the planner schedules more and more work, we would very likely see a long list of operations being performed on this day, and eventually those green boxes are going to turn pink as the capacity gets used up. When that happens, then drag and drop capability within this program allows the planner to very quickly drag operations to days that are not overbooked or over capacity. That way, very quickly, seeing how the schedule can be smoothed out so that all of the demands can be met. If the demands can't be met because they're over capacity for too long a period of time, well, they still can use that information now to determine perhaps some of the underutilized work centers could be put into use. Perhaps an outside resource might have to be used, but it gives them the information that they need to make decisions so that they can meet the requirements of the system. Well, in our time together today, we've really taken a very, very high look at the planning tools that are provided by the ERP system and the setup that's required in order to have those planning tools work properly. But hopefully, as we've gone through this information, it's demonstrated how the ERP system both collects information and what's required to allow it to collect that information, and then how it uses that information to plan the shop floor. So what's next? Where are we going to go from here? Well, in our time together, we've covered the bills of materials and the routings, but the ERP system touches a whole lot more than just the activity there on the manufacturing floor. We touched on work orders just a little bit today. Work orders are demands on the system to create something, to manufacture something, as opposed to buying something, buying parts. So typically, work orders are created by the MRP system, and they provide supplies of manufactured sub-assemblies and final assemblies that are in line with the customer's orders. Work orders also are used by the MRP system and capacity planning to put demands on the system. MRP uses it to put demands on for material, and capacity planning uses it to put demands on shop floor capacity. So we'll be talking about that in a future webinar. We're also going to discuss order entry. Order entry, sales orders, feeds the demand side of the ERP system and allows the users to maintain customers and products and orders, always giving them an up-to-date information about where they stand with regard to customer requirements. We're also going to be talking about purchasing. Purchasing provides the supply side of the ERP system for the purchase parts that are needed to satisfy the demands. But besides just creating purchase orders, it also maintains vendors, a purchase item list, costing issues, and things like that. And of course, beyond this, there's far more that we'll be talking as the future goes on. So thank you very much, and David, I'm going to turn it back to you now.
Thanks, David. That was impressive as always. Before we get to everyone's questions, just a quick reminder that this webinar will be posted on our website at www.rootstock.com. And of course, after the webinar, if you have any further inquiries, please email us at marketing@rootstock.com. We'll now answer questions submitted during today's presentation, as well as take any new questions. And just a reminder, you can still submit questions through the questions pane in your attendee control panel. We have a few questions today, David. Our first question today is, you mentioned using a factor to consider downtime on a work center. Why not just put in a single number of hours that are actually available and forget the math?
That's a good question, and actually some ERP systems do exactly that. Rather than provide a factor that would affect the total time, total capacity in a work center, they provide a single field and say how much time do you want the capacity planning tool to use. The problem that arises there is that the time that is available is fluid. Suppose one day you have 3 workers who call in sick. Well, that could affect the capacity for the day. Or maybe a machine is down for repairs or whatever. That could affect the capacity. And so when you have a scheduling factor, no matter what the number of hours you have available is, it's always going to be used to give the capacity planning system an accurate number of hours. So as those hours change, you want the ability to have a factor on them that says only plan this many hours, even though we have capacity more or less than that.
Okay, very good. Our next question is, how does ERP handle runtime that is for the entire work order amount instead of for each piece, like, for example, heat treating?
Okay. Again, this is the answer to that question is based on which ERP system you're using. In the Rootstock system, runtime has a flag on it that where you can say that this is runtime for the entire batch of parts that are being made or for an individual part. Typically, it's for an individual part, but as the question, the example, it could be heat treating, where almost an unnumberable amount of pieces would be put into a furnace to be heat treated over a long period of time. Obviously, you're not dealing with the time for one piece anymore. The run time, the time the heat treating actually takes, is for a number of parts. So that flag that Rootstock provides is the way Rootstock handles that issue.
Okay, excellent. Our next question is, should packaging and shipping time be included in the routing?
Once again, this is based on it depends on the ERP system that's being used. Rootstock provides that kind of time and scheduling for shipping, and so it's typically not included in the routing. But it certainly can be. Shipping could be another work center, and it could be scheduled exactly like any other work center. So this is kind of up to the user and the ERP system to decide.
Okay, very good. I have another question, but David, I think I can answer this one. Somebody wrote in, where can I learn more about how I can use Rootstock to manage the shop floor? The answer to that would be visit www.rootstock.com. You can visit the webinar pages. You can go to our resources tab and go down to the ERP 101 option and click on that. You can also click on schedule demo button on the up in the top navigation bar to request further information as well. Okay, I think that wraps up our questions for today. So David, thank you very much. And before we end today's webinar, I'd like to present a brief look ahead at the upcoming topics in our ERP 101 webinar series. Today, we covered shop floor. See how scheduling the shop floor through ERP controls labor and machines. The next webinar in the ERP 101 webinar series by Rootstock Software is scheduled for November 29th, and will cover the topic procurement. Link your vendors and purchase parts via ERP. Future webinar dates are to be announced. Thank you all very much for joining us today. We look forward to seeing you at our next webinar. Today's webinar is now over.